Hello, and welcome to part 2 of this series on programmable logic controller programming. And we're going to be using the Rockwell Automation Connected Component Workbench, also known as CCW, to be teaching you how to program PLCs. I chose CCW and the Rockwell Micro 800 series because, one, the software has a free version for it, so to get started, you won't have to lay out any money. And also, two, when you go to start adding hardware, the hardware is very inexpensive and very powerful at the same time. Now, if you're new to PLCs and PACs, PLCs, first of all, stands for Programmable Logic Controllers. PACs stand for Programmable Automation Controllers. You should know that PLCs, when they are initially invented, were invented to be relay replacers. Automated factories, up until about 1968, were controlled by thousands of electromechanical relays. With the advent of the electronics and the digital electronics and computers in the late 60s, manufacturers wanted a way to eliminate all the hard wiring that went along with electromechanical relay control, and to make something that was easier to make changes, easier to update from one manufacturing or one product type to another, and was also a lot more energy efficient. So PLCs were invented. I think it's always a good idea, like again, if you've never done PLC work before, or even if you have, and just want to know a little more, I always like to learn a little bit about the history of a technology before I really start diving into it. I put a link in the description box below to my website, and please, my website is very much under construction. All right, so forgive the crudity of it, but there I put a link to the website where I have a history of PLCs listed, and you can go in there if you'd like, and it's a short history of where they came from, why they came about, who invented them, and how they became an integral part of any automated system. So I encourage you to go ahead and take a look at that. Now, in the first video of this series, which you may or may not have watched, we talked about the CCW software as being a standalone development platform that has an integrated architecture such that one software program can program PLCs, human machine interfaces, HMIs, variable frequency drives, motion control, safety relays, and really the whole realm of a factory automation, or even a simple home automation type project. So I would say that if you want to follow along with these lessons or these tutorials, and you have not downloaded and installed CCW, go to that video, and I'll also put a link in the description below to that video where it will show you where and how to download CCW, because CCW is a wonderful program. There's some things that you need to do prior to the installation of that, and that's all talked about in that video. Now, if you've already installed CCW, let's get started on this little tutorial. We're just going to enter one simple rung, but before we get started, let's launch the software. please use version 12 of the software. Version 12 is the only version that includes a simulator so that you don't have to have actual hardware in order to run any of these programs. If you have an earlier version, you won't have access to the simulator. So to launch the software, after you have it installed and everything's set up, you can either double click on the desktop icon, and I moved mine to a location, or you can get it through the Windows Start menu by clicking the Windows Start button, scrolling through your list of applications, looking for Rockwell Automation, and drilling in, and then saying Connected Component Workbench. And I'll just click there to get the software started up and running. Now, the first time you launch it, sometimes even after that, it takes a little while for the software to start up, and you'll see the splash screen just like you see on my screen. But once it starts up, you get the environment that you see on the screen at this time. The very first thing you'll see is a start page and a project organizer. So it's a dual pane window, and actually there's more window panes that we can open later, so it can get pretty busy. You probably want to think about using a larger monitor or even two monitors when using this, but you know what, I'm running on a very small laptop right now, and for what we're going to be doing in this first couple of lessons and first couple of videos, you don't need anything except whatever you're running. Now remember, as I told you in the last video, or in the video that where we installed the software, this software will not run on a Mac, and this software will not run in Linux. So you have to have Windows 7 or Windows 10, and I highly recommend Windows 10. Not that I like Windows 10, I just highly recommend it. Besides, support for Windows 7 is going to be ending shortly. Anyway, you've got the start page that comes up, and there's three different areas within this start page that are available to you. One is this project area, and in the project area, you can create a new project, you can open existing projects. This discover option is if we have hardware connected and we're on a network, we could click on that and we could actually discover and find the hardware that's on the network in case we want to do any programming directly to that hardware. You'll also see an area for recent, which is recently opened projects. Just like any Windows software, there's usually a place where you could see what you've recently opened. And then there's also a getting started area. And this area will take you to the Rockwell website. The Welcome to Connected Component Workbench will take you right to the area where you would have downloaded the software. And then there's also some training videos that Rockwell created, and they're actually very good. I would highly recommend that you might want to go ahead and take a look at them, but they're really made for people who have been working with PLCs for a while, who are making the switch over to CCW, who are, coming up the curve on learning a new platform and a new software. But please, Rockwell is a great company to work with. And again, I am not a Rockwell representative. I am not selling Allen Bradley equipment. I just happen to use them because I'm in the northeastern part of the United States, and they happen to have a huge market share here in the northeast of the United States. So that's why I use them. Now, there's also a checkbox down here at the bottom which says show this page on startup. If you don't want to see the start page every time you start the software, just remove the check from that box. I leave it checked. It's not really, this window's not in my way. As you can see, there's a tab, and you'll see multiple windows in this area. So they're tabbed anyway. You can close them, you can reopen them, you can collapse them. So there's a lot you can do to keep yourself organized. So let's start a new project. Now, like Windows applications, there's multiple ways of doing the same thing. I can come under projects and I can click new, or I can do file menu, say new. Either way will get you to the same place. So while I'm here, I'm just going to say new, and you will get a new project dialog box opened. And in this dialog box, there's a name field, and we have to give this project a name. I normally like to give a name to a project such that it tells me the purpose of this project. So if I'm writing a program to control a conveyor belt, I might name it conveyor line 2, or maybe furnace 1. So give it a name that's worth it. For this project, you know what I'm going to do? I'm going to say my first project, because this may be your first project. Okay. The next thing is the location. Where do I want to store this project? Right now, I have my project set to go into a folder called My Stuff, Micro 800 Projects. Yours will be different. CCW has a default project path, and if you want to use that path, go right ahead. That's fine. I'm actually going to change this project location, so I'm going to browse and bring up my browser, and I'm actually going to go up and save it in my Dropbox so that I have access to this project wherever I happen to be working, as long as I have internet access. So I'm going to find Micro 800 project folder, and I'm going to say, sorry. I'm going to click on Micro project folder, and then I'm going to create a new folder here, and I'm going to say my first, maybe. Let me click in there again, because I think what was happening is things are getting updated. Let me do rename and say my first project. Press enter and say OK, and you'll see that it is now going to go to that particular project. There's a checkbox here, add device on create. If I leave that checked, when I create this project, it's going to ask me if I want to install some hardware. I'm going to leave that box checked for now. Even though we're not using actual hardware, we are going to be adding the simulator, which is basically hardware. So I'm going to leave that checked. If you have the box unchecked, you can still add new hardware. And I'll show you that and how to do that in another video. So I'm going to leave it checked, and I'm going to then press the create push button. And after some grinding away, and sorry, my printer's doing a clean cycle right now. That's what you hear in the background. You'll get an add device dialog box. And you'll take note that you can select the devices from a catalog. There's controllers, there's the drivers, drives, there's motor control, safety, HMIs, which are graphic terminals. So we're going to select the controller. So click on the little arrow to the left of the folder to drill into this, and you'll see that there's a list of Micro 800 controllers. The simulator is an 850, so we're going to drill into the Micro 850 controller. And if you look down the list, you'll see there's a whole bunch of different 850 controllers, but there's one right here at the bottom of the list, the 2080-LC50-48QWB-SIM, SIM. That's the one we want. We're going to click on that because that's the simulator. In the selection dialog box, you'll see a picture of the controller come up. You'll also see a version number and a description and some additional description items. You can look through that, and just right now it's not important, but when you start getting new hardware, you might want to take a look at that box. Also, the version number. If I drop this down, you'll see I only have one version. That's because the simulator is version 12. I want you to know that this version number is not the software version. When we start using hardware, the hardware does not come with what's called firmware. In the computer world, it's called BIOS. So it does not come with firmware. I mean, Rockwell doesn't know what firmware you want to run. It doesn't know what you want to do with an item. Most PLCs that I'm familiar with, when you buy a new PLC, brand new, it does not come with firmware. You're going to have to go to the manufacturer's website and download the firmware version that you want to use. The latest version for CCW, or for the Micro 800 series, is version 12. So you would select here the version number of the firmware. So I can easily use software version 12 with firmware version 10 if my hardware happens to be version 10. So we'll leave that at 12, and then we will click the select button. When I was new to CCW, I'd often forget to click that select button and then wonder, why didn't my hardware show up? Well, it's because I didn't select it. So we're going to click select. The box collapses. It shows you that it's been selected. If I make a mistake, it's real easy to change. I can either change it, or I can click this little trash can over here and it'll delete it, and I can go back and I can add the right hardware that I want. The select existing device hyperlink up here in the corner, that is also if you have hardware connected to the network and you want to add it to this project, you can click on that link. It'll open up an RS Links window. RS Links was installed with CCW. RS Links is the communication software that comes with Rockwell softwares. It's used to communicate between the computer and the PLC, or between PLC to PLC. So if I have hardware and I want to add that particular hardware to this project, I can select an existing device which is sitting out on the network someplace. We don't have that, so I don't have to worry about it. Once I have, we're only going to do this simulator. That's all we're going to use right now. So down at the bottom, let's add this to the project, and we'll click add to project, and it'll churn away. It's going to be creating the project. Once it's created, you'll see that there is a graphical picture of the 850. There are some add-ons that you can put on here. If I hover my mouse over here, you can see that I just had to move my mouse out. You can see that I can add things or add other modules and plugins to this particular device. We literally don't have to make any changes to this simulator at this time. We're going to leave it as is. But for future reference, each one of these items in the front are just dust cover doors. There's plug-in modules that can be purchased to plug into the front end of this to expand its capability. You can do analog inputs, analog outputs. There's a bunch of different plug-in modules, and they're all very affordable. This particular 850 series also communicates over Ethernet. That's probably the preferred method for communication these days. Other 800 series processors may have different communication methods. So if you're working on a network, or if you are going to be installing this on a network that is not Ethernet, that might be USB, it might be RS-232, or some other type of network, make sure you get the right hardware to go with the right network, because not all 800s will communicate across any network. All right, so we don't have to do anything at all to this simulator area. Let's go over to the project organizer. You'll see that there's the 850, and under the 850 we have some items: programs, global variables, user-defined function blocks, user-defined functions, and data types. I'm planning to cover all of these items in future videos. This software is very powerful for the fact that it's free. There is a paid version for this, which adds even more functionality. But for a free version of software, this is very powerful software. Now, under programs, PLCs can be programmed in several different languages, and projects can contain routines that are written in different languages. This particular PLC series can be programmed in 3 different languages. One of them is Relay Ladder Logic, or RLL. It's probably the most common language used for PLCs. It's commonly used because they were originally designed to be relay replacers. So when you have an electrician in the field who's got to maintain this system, who has to be working to get this line up and running if it ever fails, they're used to reading electromechanical ladder logic. So writing the program in a way that is familiar to them makes their learning curve much shallower, so that they can be more efficient in their job. So relay ladder logic is one method, and that's the first method I'm going to be showing you. Another method of programming is function block diagram. Function block diagram is a graphical language that uses blocks that have code functions, and then you wire the blocks together to perform the operation, or the logic of the operation. And then there's structured text. Structured text is just like using what I call a higher level language, such as C or C++ or Python. That I consider those a higher level language. It's a text-based language. PLCs have their own syntax to that structured text. It's very similar to other languages. If you know one language, coming up the curve on another one is fairly easy. You just got to learn that syntax. Now, I've been teaching PLCs for 28 years or more, and one of the things that new students ask me is, why all the languages, and when would I use one language over another? There's really no one simple answer to that question. First of all, a lot of times the programmer will use whatever language they are familiar with. So if they're more familiar with ladder, they're probably going to program in ladder. If they're more familiar with function block, they may program in function block. But also, some of the instructions are only available in certain different languages. So you may be writing a program, or need to write a program, that has the need of an instruction that is only available in function block. Therefore, you're going to have to use the function block language in order to write that program. But they'll ask me, why would I want to use these languages? Well, one of the things is that if I have an application where there's a sequence of operations occurring. You know, step 1, step 2, step 3, step 4, etc., go on, and then back to step 1 and repeat, and then repeat all that, and back to step 1 and repeat all that. I'm going to use ladder logic for that. Ladder logic programming is designed for sequential operating type equipment. It makes the operation and the programming very simple, very easy to read. If I have a lot of computations to do, if I have a lot of math functions to do, if I'm calculating, vessel sizes and vessel levels and flow rates and stuff, I'm going to use structured text. I'm going to use a textual language, because the textual language, mathematics, and all those computations are done so much easier and a more user-friendly type look to them. If I'm in a process industry such as food processing, beverage, pharmaceuticals, biotech, chemical, someplace where I'm dealing with different materials being blended and mixed and heated and and stuff, I'm going to use function block, because function block programming has a lot of instructions that are specifically intended for the process industry. So depending on what you're doing and what application you're programming is going to really determine what language you'd like to use. All right, enough of that. So let's go on and create our first project. So to create the project, we're going to come over to the project orienter, and under programs, we're going to right click on programs, and then slide down to the add, and we're going to select new LD, or ladder diagram program, because we're going to create a ladder diagram program. We'll select ladder diagram. You'll notice that under programs, we now have prog 1, and the icon to the left of it, if you look at it close enough, it kind of looks like 2 rungs of a ladder. And under prog 1, there is an area for local variables. In PLCs, there are local variables and there are global variables. Local variables are only, the values that are stored in them are only available to that particular program or that particular routine. Global variables are available to the entire project and all routines. And we're going to talk more about variables and what they call scope. The scope of the variable. Where is it available? How long is it available? Later on in a video, in a more advanced video. We got the next thing the next thing we're going to do is we're going to rename this program. You should name the routines. They're actually routines, even though they call them programs. You should name the routine in a way such that somebody looking at this knows what that particular routine function is. Well, I'm from the old school yet. I grew up through the DOS days even. So every program had what's called a main routine. So I kind of work in that flavor yet. So I'm going to rename this to main, and all I'm going to do is come over and right click on that program, and I'm going to select rename, and I'm just going to type the word main and press enter. You can call it anything you want, at least for this project. To open up that program, because that program didn't get opened up yet. To open that program, I'm just going to go over and I can either right click and say open, or I can just double click on it and it'll open. It's opening the file, and it will open as another tab in this main window. It adds automatically a blank ladder rung. The power rails are shown on the sides with 1 rung. There is an instruction toolbox across the top, And there's also a category of instruction navigation bar, I call it. Rockwell, I'm not sure what Rockwell calls it, but it's an instruction selector that groups different instructions so that they're easier to find when you're looking for them. We won't need anything except the favorites, which is selected by default. If I come over along the right edge, you'll see that there's a toolbox and a properties. If I click on toolbox, these instructions are also available in this flyout toolbox. They're exactly the same. Previous versions of this software only offered this toolbox. So I'm going to just collapse that toolbox again, but I just clicked out of it and it collapsed. So we're going to add a new rung, or we're going to add some instructions to this rung. And what we're going to do is we're going to build a simple start-stop circuit. That's what everybody builds. You know, it's like when you get a new piece of software, you write a program code, you write a program that says, "Hello world." Well, I think the start-stop rung in PLCs is the hello world. At least for me it is. Now, for those of you who are not familiar with this, normally there are electromechanical switches and sensors wired to the hardware or wired to the PLC. And then you'll be accessing that hardware in the program. It's very similar to an Arduino if you've ever done anything with Arduinos, as far as accessing field devices and sensors. Normally, not normally, but all the time, stop push buttons are normally closed switches in the field. So out in the field, the physical stop push button is a normally closed switch. The start push button is a normally open switch. And we're going to deal with how the field device status affects how you write the program in another video. Actually, I already have a video in YouTube that talks about why you program instructions one way for field devices, and excuse me, I won't go there right now. But we're going to build this start-stop rung for the simulator. So the first thing we're going to do is we're going to add the stop push button. The stop push button is normally closed. So I'm going to come across this toolbar under favorites, and I'm going to find a normally closed contact. This normally closed contact is also referred to as a reverse contact or an examine if open contact. I'll talk to you more about that naming structure also in another video. I don't want this video to get longer than it already is getting. So you take this instruction, you click on it, and you drag it down to the ladder rung. And when you see this little plus sign appear, you're able to drop the instruction. When the plus sign is not there, you can't drop it. If I drop it, nothing happens. So I'm going to drag this instruction down until I get to the plus sign, and I'm going to drop it. And as soon as I drop it, a window opens up that's called a variable selector. And it kind of looks like an Excel spreadsheet because it's really a database window, which is a table. And it's a tabulated table. You'll see that right now the local variables for main, which is the name of my program, is in focus. You'll see that there's user global variables, system variables, I/O, and defined words. We're going to leave it at local variables, and across the top you'll see a name area. This name field is where we're going to give the variable a name. Well, this is a stop push button, so I'm going to name this stop PB. I'm using something I believe is called camel variable naming or camel hump, where when you have multiple words in a variable, the first word uses lowercase and then every other word uses uppercase. I'll talk more about that also in another video. But for right now, I'm going to call it stop push button because that's what it is. It's going to be the button to use to stop the machine. The next field over is type. This is a data type. If you don't know about computer data types, if you don't understand numbering systems such as binary and octal and hexadecimal, I'm going to create a video on that, although there are already a lot of videos on YouTube that talk about that. The way I teach number systems is a little bit different than some other people because I think it's easier than what most people make it. You don't have to do all the math. All you have to do is know how to add and subtract, and you can do these number things. But anyway, this is a switch. So the switch has two states on it. It's either on or it's off. It's either open or it's closed. A 0 or a 1. It's a Boolean state. So we're going to name the type bool. It's a data type. We're going to leave the scope at micro 850, and we're going to leave the local scope at main. So with the name of the tag or the name of the variable in the name field, we're going to say OK. And it adds that instruction to the rung and lists the variable name. If you hover your mouse there, it'll tell you name, stop, push button. The data type is bool. The next item we're going to add is the start push button. And then we have to have an output coil for this rung. But I want to show you another way of doing this. Sometimes it's a convenient way to create all the variables first and then go in and assign them to instructions. So that's what I want to do. So to create the variables without having an instruction on the rung, come over to the project orienter and we'll double click on the local variables object that's under our main program. So I'm going to double click on this, and it's going to again open up an Excel spreadsheet type looking page. Again, this is the database for this. And you'll see that there's several columns: name, alias, data type, dimensions, and so on and so forth. And under the name column is the variable name. Now, the bottom row has an asterisk there, a star, and that's the row where we're going to create another tag. So if you click into the name cell in that row, let's create a start push button. And I'm just going to call it start push button. PB. All we're going to need for this program is, is a data type. And we want that also to be bool. It's a switch. It's either a 1 or a 0. So it's got two states. And I don't need anything else. I'm going to press enter. It accepts that variable and it automatically creates a new row so that I can create a new tag. Let's create one more tag, and I'm going to call this tag run control. This is going to be the output coil for this rung. I want to remind you again, this is relay replacement logic. So you have contacts and coils, just like you have in an electromechanical relay. I'll also leave a link down in the description if you don't understand relays. That will take you to a video that somebody else on YouTube created that I think is pretty good, that will teach you how and what a relay is and how they work. The run control, since it's a coil, coils have two states. They're either on or they're off. So we're also going to need this as a bool data type, and we'll press enter. That's all we need for this one rung. So now I want to go back to the ladder. The ladder, I can either come over and double click on the main, or it's already open if I go across these tabs, and I'm going to just click on main to bring back the ladder logic. Now, start push buttons are normally open. So I'm going to grab a normally open switch, which is also called a direct contact or an examine if closed contact, and I'm going to drag it to the rung, and I'm going to drop it. Notice now I have two plus signs, and wherever the plus sign gets bigger, highlights, is where I can drop it. Well, I want to drop this to the right of the stop push button. So I'm going to drop it on this plus sign. The variable selector comes up just like it did for the stop push button. Only this time I see the tag or the variable stop push button that I created previously, but here's the other two variables I created. This is going to be the start push button. So I'm going to click on start push button or start PB and say OK. And it assigns that variable to that instruction. The next thing I'm going to do is I'm going to take a coil. So the coil is this little ovally, circly shape item. It's a direct coil, also called an output energize. And I'm going to drag this instruction down, and I want to drop this. Notice I can only drop this to the right of that start push button. So I'm going to drop it there. The variable selector comes up. I want to call this run control. So I can click on run control and say OK. The reason why I could only add that to the right of the start push button is because instructions in ladder logic are classified as either being input instructions or output instructions. Input instructions are always on the left side of the rail, of the power rail, or I'm sorry, of the rung, and output instructions are always on the right side of the rung. Normally open contacts, normally closed contacts are input instructions, and output coils are output instructions. I'm going to turn some light on in here. It's getting cloudy outside. We need one more thing. The next thing I need is the push buttons that are in the field are usually momentary, meaning that when you press it, it changes state, but as soon as you release it, it goes back to its normal state. So that means that I have to seal in the operation of this start push button. So I'm going to put a contact around that start push button. So we're going to branch. We're going to add a branch, it's called. And on the toolbox, there is a branch tool. I'm going to drag this down and I'm going to drop it actually in between these two instructions. Now, my start push button went right where I wanted it. But if your branch, and I'm going to drag this out of here, if your branch did that, not a problem. Notice what I did. You can take instructions, click on it, and drag them to wherever you need them. Very powerful operation. I'm now going to add another normally open contact to this empty branch. I'm going to drag this normally open contact, and I'm going to assign it to run control and say OK. So when I apply power to this rung, this contact is closed. When I close the start push button, I will have power flowing from this left power rail through the two switches to the coil. It'll energize the coil. When the coil energizes, any contacts that are programmed to it will change states. Again, if you don't understand relays, there's go down to the description box and click on the link for understanding relays. So when that energizes, this contact will close so that when I release the start push button, current will continue flowing through the stop push button, through the run control, and to keep that coil turned on. If I want to stop this, all I need to do is press the stop push button, which will open this. Current will stop flowing. The relay will de-energize. Its contact will open. When I release the stop push button, these two contacts will be open and the coil will no longer be energized. So I'm going to stop this video at this point because I think it's getting a little long, and Come back to the next video and I'll show you how to download this to the simulator.